So we're given two functions. One is square root of x and the other is kx squared, where k is any constant. And we want the slope of the tangent line of f at the point 4, 2. So to find the slope of the tangent line, first thing we need is the derivative, f prime of x. Well, it may be easier to write f of x as a power function, so x to the 1/2. And so then f prime of x is 1/2 x to the negative 1/2. Or if you wanted to simplify that, because it's negative, the x will go in the denominator, and 1/2 is a square root, so 1 over 2 square root of x. Now that just gives us the derivative. To find the slope of the tangent line, we need to find f prime of 4, and then we're going to plug 4 into our derivative. 1 over 2 times the square root of 4 is 1 over 2 times 2, or 1/4. So there is the slope of our tangent line at the point 4, 2. To find the tangent line that goes through the point 4, 2 with a slope of 1/4, if we wanted to use point slope form, we could say, okay, well, it's y minus 2 equals 1/4 times x minus 4. Or if we wanted to solve this for y, say we wanted to graph it, we can add the 2 over, so we get y equals 1/4 times x minus 4 plus 2, so you'll see it in this way sometimes. The other way we might write it is in slope-intercept form, which is by distributing the 1/4. So we're going to have 1/4 x minus 1 when we multiply the 1/4 times a negative 4 plus 2. So in slope-intercept form it would be 1/4 x plus 1. So there's our tangent line. Now if we wanted to assume that G also contained the point 4, 2, then we need to find K to make sure that that happens. So we need that G of 4, which is K times 4 squared, equals 2. So there's the equation that we need to solve to make sure that this happens. So that's going to give us K, 16K, equals 2, and if we divide both sides by 16, k equals 1/8. So then g of x is actually 1/8 x squared if we require it that it goes through 4, 2. So the last question then is, where does g intersect the tangent line from 2, which was our, so we're looking for where y equals 1/8 x squared intersects y equals 1/4 x plus 1. A couple different ways we could go about solving this. One of them is we could set them equal to each other and see what happens. So we're going to have 1/8 x squared equals 1/4 x plus 1. And because we're dealing with a quadratic, we're going to need to get this equal to 0. So I'm going to come right over here, and I'll have 1/8 x squared minus 1/4 x minus 1 equals 0. And instead of dealing with all those fractions, I'm going to multiply everything by 8. Essentially I'm doing that to both sides, but because this is 8 times 0, it won't change anything. So I'm not going to change the zeros of my function. What I will do is get rid of the fractions, because 8 times 1/8 is 1, so I get x squared. 8 times negative 4th is negative 2x. And finally, minus 8 equals 0. And now, this is something that will factor into x minus 4 and x plus 2. And I get two values from this. I get x equals 4 and x equals negative 2. Now I was asking, where does G intersect the tangent line? Well, if we look, we already know that G of 4 equals 2, we forced it to, and also with our tangent line, we know that if we plug in 4 that it equals 2, because that's the point we made it go through. So they intersect at the point 4, 2. Now we have another point here, at negative 2. So let's see if they also intersect at negative 2. Now if I plug negative 2 into G squared, I get 4 times 1/8, I get 1/2. Now to see if that goes through, if that's also on our tangent line, 1/4 times a negative 2. Let's just write this down here. 1/4 times a negative 2 plus 1 is negative 1/2 plus 1, or 1/2. So we have two places where our tangent line intersects this quadratic.